Hey there, science fans! Have you ever looked up at the night sky and wondered how we get those giant rockets into space? It's a question that has fascinated people for centuries. Rockets are those awesome vehicles that blast off from Earth, carrying satellites, telescopes, and even astronauts to explore the vast universe. What is it about rockets that make them so cool? Maybe it's their sheer power, their ability to defy gravity, or the promise of adventure they represent. Whatever it is, one thing's for sure. Rockets are totally rad. They are marvels of engineering and ingenuity, and understanding how they work can be an exciting journey into the world of science and technology. So buckle up as we embark on a thrilling ride to uncover the secrets behind these incredible machines. Get ready to learn about the different parts of a rocket, the powerful fuels that propel them, and the amazing things they help us achieve. From launching satellites that connect us globally to exploring the mysteries of distant planets, rockets play a vital role in expanding our understanding of the cosmos and our place in it. Building a rocket is a bit like putting together a giant, super complicated Lego set, but instead of plastic bricks, we use strong metals, powerful engines, and tons of fuel. It's a delicate and complex process that requires careful planning and incredible precision. So what exactly goes into making a rocket? Well, let's start with the materials. Rockets need to be strong and lightweight to withstand the immense forces of launch and space travel. That's why they're often made from materials like aluminum, titanium, and even composite materials, which are like super strong mixtures of different stuff. These materials are carefully shaped and assembled to create the different parts of a rocket, like the nose cone, that pointy thing at the top, the fuel tanks, where we store all that rocket fuel, the engines, the heart of the rocket, and the fins, for stability during flight. It's like a giant jigsaw puzzle, and every piece needs to fit perfectly for the rocket to work. Just like cars, rockets come in different shapes and sizes, each designed for a specific job. Some rockets are small, like the ones used for sounding rockets, which are like little rockets that scientists use to study Earth's atmosphere. Then there are the big guys, like the mighty Saturn V, which was used to send astronauts to the moon. One way to classify rockets is by how many stages they have. Think of stages like separate sections of a rocket, each with its own engine and fuel. Multi-stage rockets are like those Russian nesting dolls. As one stage uses up its fuel, it detaches and falls away, making the rocket lighter and allowing it to travel farther. We also have different types of rockets based on their purpose. Some are designed to launch satellites into orbit, others to carry scientific instruments to study planets, and some, like the Space Shuttle, were even designed to carry astronauts to and from space. It all depends on the mission. When we think of rockets, we often picture astronauts blasting off to explore the cosmos. And while space exploration is a huge part of what rockets do, it's not the whole story. Rockets play a vital role in many other fields, from communication and navigation to weather forecasting and national defense. For example, ever wondered how your GPS knows exactly where you are? Thank a rocket. Satellites launched into orbit by rockets provide the signals that power our GPS systems, allowing us to navigate with incredible accuracy. Rockets also launch weather satellites that help us track storms, predict weather patterns, and even monitor climate change. These satellites beam back valuable data that helps us understand our planet better and keep people safe from natural disasters. Section 5321, liftoff, fueling the fire. Alright science fans, time for the really exciting part. How do we actually launch these massive machines into space? It all comes down to one word: thrust. Rockets generate thrust by burning fuel in a controlled explosion, which creates hot gas that's blasted out of the rocket's engine. This creates an upward force that propels the rocket skyward, overcoming the force of gravity. But what kind of fuel is powerful enough to launch a rocket into space? Rockets use a variety of fuels, but the most common types are liquid propellants and solid propellants. Liquid propellants like liquid hydrogen and liquid oxygen are extremely powerful, but also require complex systems to store and manage. Solid propellants, on the other hand, are like giant firecrackers. They're pre-packed and ready to go, making them simpler to handle but less controllable once ignited. It's like choosing between a gas stove and a bonfire. Both can cook your food, but they require different approaches. Section 6. Rocket champions, strength and speed. Over the years, we've built some seriously impressive rockets, each pushing the boundaries of what's possible. When it comes to pure strength, the title of most powerful rocket ever built goes to the mighty Saturn V, the behemoth that carried astronauts to the moon during NASA's Apollo program. This colossal rocket generated a mind-blowing 7.6 million pounds of thrust at liftoff. But what about speed? The fastest rocket ever built is actually a bit of a trick question, as it depends on how you measure speed. If we're talking about speed relative to Earth, then the Parker Solar Probe, launched in 2018, takes the cake. This incredible spacecraft, designed to study the sun up close, has achieved speeds of over 364,660 miles per hour relative to our home planet. That's fast enough to travel from New York to Los Angeles in under a minute. Section 7. The price of reaching for the stars. Building and launching rockets is no small feat, and it comes with a hefty price tag. The cost of a rocket depends on a variety of factors such as its size, complexity, and the specific mission it's designed for. Smaller rockets, like those used for launching small satellites, can cost tens of millions of dollars, while larger, more complex rockets, like those used for human spaceflight, can cost hundreds of millions or even billions of dollars. For example, each launch of the Space Shuttle, NASA's partially reusable spacecraft, was estimated to cost around $450 million. The development and testing of new rockets can add even more to the overall cost. While the price tag for space exploration might seem astronomical, pun intended, it's important to remember the incredible scientific and technological advancements that come from pushing the boundaries of what's possible. Plus, the awe and inspiration that space exploration inspires are priceless. Section 8. Rocket factories, where the magic happens. Ever wondered where these incredible machines are built? Rockets are assembled in specialized facilities called rocket factories, and these places are like giant high-tech workshops. These factories are equipped with advanced machinery, clean rooms to prevent contamination, and teams of skilled engineers and technicians who work tirelessly to build these complex machines. The assembly process typically starts with the construction of the rocket's different stages, which are often built separately and then joined together later. Engines, fuel tanks, avionics systems, and all the other essential components are carefully integrated, tested, and retested to ensure they can withstand the extreme conditions of launch and spaceflight. Once the rocket is fully assembled, it's transported to the launch site, where it undergoes final preparations for its journey into space. It's a complex and coordinated effort that involves countless hours of work and the dedication of thousands of people. Section 9. Blast off to the future. Rockets have taken us on an incredible journey from the early days of space exploration to the sophisticated missions we see today. From the iconic image of Neil Armstrong's first steps on the moon, to the stunning images captured by the Hubble Space Telescope, rockets have allowed us to dream big and reach for the stars. The most powerful rocket ever used, the Saturn V, remains a testament to human ingenuity and our unyielding desire to explore the unknown. As we look to the future, rockets will continue to play a vital role in our quest to unravel the mysteries of the universe and expand our understanding of our place within it. Who knows what incredible discoveries await us in the vast expanse of space? One thing's for sure, with continued innovation and a passion for exploration, the future of rocket science is sure to be out of this world. Keep looking up, science fans, and never stop questioning, exploring, and reaching for the stars.